Welcome student. So this is the another class of the electrochemistry. So in this class we will read product of electrolysis. Okay. So product of electrolysis few part we have read in the application of electrochemical series. Okay. So first, what is the meaning of electrolysis? So in the previous class we have read electrolysis, the mathematical part, that is Faraday law, Faraday first law and Faraday second law. Okay. So electrolysis means breaking of electrolytes by passing electric current. That means these are the example of electrolytic cell. So electrolysis, it depends on the nature of the material being electrolyzed and the type of electrode. Okay, so electrolysis, it depends on which material we have taken inside the container, that means solution, and also depends upon which type of electrode, that means cathode and anode, we are using in this electrolysis. Okay, so that's why product of electrolysis, it depends on the nature of the material being electrolyzed and the type of electrode. Clear? Next is, if the electrode is inert, inert electrode, I-N-E-R-T, inert electrode like platinum, yes or no? So if the electrode is inert, that electrode does not take part in the cell reaction or in the electrolysis. Clear? If the electrode is inert, it does not take part in the cell reaction. Clear? Then next point is the at cathode and at anode different types of reactions takes place. So at cathode the reaction having greater inert value is preferred, and similarly at anode the reaction having less inert value is preferred. But at anode sometimes due to overpotential some reactions are not possible. Okay, so this thing can be easily understood by taking one example. Okay, so these are the example of electrolytic cell. These are the example of electrolytic cell. So in electrolytic cell we know, you see, one is at cathode and another one is at what? Anode. So in galvanic cell anode is negative, but in electrolytic cell anode is positive. Similarly, in galvanic cell cathode is positive, but in electrolytic cell cathode is negative. Clear now? Okay. So you see one example. Question is electrolysis of molten NaCl using platinum electrode. Okay, so electrolysis of molten NaCl using platinum electrode. That means here the electrode is inert. So at cathode which type of reaction takes place, and at anode which type of reaction takes place. Okay, so first you see, so here which electrolyte is present? NaCl. So in NaCl, Na is plus, Cl is minus. So is there any other ions are present? No. Try to understand. So in molten NaCl, or when we will take molten NaCl, one is Na plus and another ion is Cl minus. Clear? So you see, out of this, at cathode means at negative electrode positive reaction takes place, and at anode means positive electrode negative reaction takes place. So here you see, here we can write first at cathode. So Na plus, when it gain one electron it will become Na solid. Okay, and at anode Cl minus gives rise to Cl plus E. So So it will balance Cl2, yes or no? Like this, half Cl2. Okay, so that's why when question will come, what are the product of electrolysis using molten NaCl? So using molten NaCl, okay, platinum is electrode. So at cathode sodium metal deposited and at anode chlorine gas evolved. So here you see at cathode and at anode, cathode only one ion is present and anode is also one ion is present. So there is no competition. Hence the product of electrolysis is like this. But next question is, if in the electrolysis, means if in the electrolyte two types or more than two types of ions are present, so in that case how can we predict at cathode which type of reaction takes place and at anode which type of reaction takes place? So in this case, okay, we have to think this point, think this water concept. Clear? Understood? So this is the first question. Similarly, come to another question now. Electrolysis of, in place of molten, I'll write aqueous NaCl. Electrolysis of aqueous NaCl using platinum electrode. Okay, now see. So when you are taking aqueous NaCl, now Na plus Cl minus ion is present and water is also present. So now see, three types of ions are present. So three types of ions are present. Hence at cathode now competition takes place between Na plus and water. Which reaction is preferred here? Similarly, at anode, Cl minus and water, these two, what competition takes place? Which reaction takes place at anode? Okay, are you getting this point? So, what are the answer you see? So, these are the first we have to check the possible reaction. So, at cathode, this is one reaction. At anode, this is another reaction. Similarly, at cathode, suppose when water gain electron. Okay, so when water gain electron, then it will become dash, it will become H2 plus 2OH minus 2, 2, 4. So it is 2, so it gain how many electron? 2 electron, it gives rise to H2 plus 2H minus. Okay, correct. Similarly, Cl minus, if it loses this reaction, and if water loses, then it will become what? O2 plus 4H plus 4E, 4, so 2. Clear? So these are the two possible reactions. Okay, now see. So at cathode, how many reactions we have written? At cathode 2 reactions and at anode 2 reactions. Now come to the theory. At cathode, the reaction having greater inert value is preferred. Clear? So Na plus and water, yes or no? Their inert cell value this. Clear? So between this, we have to check the data from the book. So Na plus, its inert value is minus 2.87 volt, minus 2.87 volt, and water when it gain 2 electron, its inert value is minus 0.83 volt. Okay. So at cathode, you see, so between these two, so whose inert cell value is greater? This value is greater. This value is greater. This is minus, no? Okay. Similarly, so at anode, which reaction? So chlorine, its inert cell value is how much? Around plus 1.23 volt, and water inert value is 1.36 volt. 1.36 volt reverse. Water is 1.23 volt. This is 1.36 volt. Now see. So come to the theory. At anode, the reaction having less inert value is preferred. Okay, less inert value is preferred. So you see, but sometimes due to overpotential, some reactions are not possible. Sir, what is the meaning of this concept? What is the meaning of this concept? So you see, you will remember, according to our NCERT book? Yes or no? Sir, how can you remember in which case overpotential? So what is the meaning of first overpotential? Overpotential means you see Cl minus after loss of electron it gives Cl2 gas. Water after loss of electron it gives O2 gas. So though its inert value is less, you see, though its inert value is less, water inert value is less, still which reaction is preferred? The chlorine reaction is preferred. Why? Now due to overpotential. Overpotential between Cl minus and water or oxygen. So what is the meaning of overpotential? Overpotential means we are passing electric current so that electrolysis takes place. So to break water molecule to produce O2 and Cl minus to produce Cl2 gas, more amount of electricity is required to break water molecule. Hence, though its inert value is less, still which reaction is preferred? Cl minus reaction is preferred because due to overpotential. So in our syllabus, according to our book, you can remember only between Cl minus and water, yes or no, water inert value less, still this reaction is not possible, it is due to overpotential. So when Cl minus and water will come at water anode, which reaction is preferred? Cl minus reaction is preferred. Got the idea? So in the question, so our question was, what is the electrolysis or predict the electrolysis of aqueous NaCl? So at cathode which reaction preferred? At cathode hydrogen, you see, at cathode this reaction preferred, at anode this reaction preferred. That means at cathode hydrogen gas evolved, at anode chlorine gas evolved, and the medium of the solution become alkaline in nature. Why? Because at cathode Na plus and anode OH minus, you see, Na plus, both are cathode Na plus and OH minus. This Na plus and OH minus combine with each other to give NaOH. So the resultant solution is alkaline in nature. Clear now? So due to alkaline in nature, its pH value increases. Got the idea? Again I am telling, you see. So when in the product of electrolysis, question will come, predict the product of electrolysis of molten NaCl. So in molten NaCl there is no problem because molten NaCl means one is cathode, another one is anode, two ions are present, so there is no problem. But when in aqueous, when there is in aqueous NaCl, there is a competition. So at cathode between Na plus and water inert value is greater, hence at cathode hydrogen gas evolved. Similarly at anode Cl minus and water chlorine gas evolved. It is only due to overpotential. Clear now? So that's why you can remember like this. Come to suppose third question. Another question suppose. Question is electrolysis of aqueous AgNO3 using silver electrode. So here you will see, here electrode is not inert. Here the electrode is not inert. So that's why you see, so first is at water, cathode, negative electrode, and another one is at anode, positive electrode. Now see, so aqueous AgNO3 silver. So aqueous means water is present, silver nitrate means Ag plus NO3 minus is present, and silver electrode is also present. So here you will see four species are there: water, Ag plus, NO3 minus, and Ag. So at cathode positive reaction. So positive reaction means either water or Ag plus. Only these two reactions are possible. So between these two, whose inert value is greater? Ag plus inert value is greater. So at cathode, Ag plus, when it gain electron, it will become Ag solid. Okay? Similarly, at anode, whose inert value is less. So at anode you see, At anode, the competition is water, silver electrode, and NO3 minus. So 3 species are there at anode. So there is a competition between them which can lose electron. So out of these 3, whose inert value is less? So silver inert value is less. Okay, so you can remember this part. So silver solid, it gives rise to Ag plus aqueous plus E. So in this question, what is the electrolysis of aqueous AgNO3 using silver electrode? Sir, at cathode silver metal deposited, at anode silver metal, you see, silver metal decomposed. So we can say this is one example of electroplating. This is, you see, at cathode which metal deposited? Silver. So this is one example of electroplating. Similarly, suppose another question will come, electrolysis of aqueous AgNO3 now using platinum electrode. So platinum electrode, it is an inert electrode. So platinum cannot take part in this reaction. Yes or no? So that's why you see. So this reaction is not possible for this question. That means here Ag cannot participate because electrode is what? Platinum. So now competition is water and NO3 minus. So whose inert value is less? Now water inert value is less. That means at anode water what loses? So water loses means O2 plus 4H plus 4E2. That means, so fourth question is, when predict the product of electrolysis of aqueous AgNO3 using platinum electrode at cathode silver metal deposited, at anode oxygen gas evolved. Clear? So this type of question you will remember because theoretical question, MCQ type question, yes or no? 1 mark question, 2 mark question. So variety types are coming. So you have to remember. So first you can remember, you see, suppose everything you suppose, sir, I forgot everything. So first you will try, sir, I will compare with galvanic cell. So galvanic cell, anode, lonesika. Galvanic cell, anode, sir said anode is negative, but here anode is positive. So positive means negative reaction takes place. Okay. Similarly, galvanic cell, cathode is positive, but here cathode is negative. So negative means what? Positive reaction. Yes or no? Positive means negative reaction takes place. Clear now? And one important part is only between water and Cl minus, though water inert value is less, but due to over potential, Cl minus reaction is preferred, water reaction is not preferred. Clear now? So like this, what your product of electrolysis, this is our qualitative aspects of electrolysis. Quantitative part, last class we have completed this part. Faraday first law and Faraday second law. Clear? See this.